Guadalupe Peak in Texas is 8,759 feet high. Sierra Blanca Peak is 6,894 feet high. Rounding to the nearest hundred, which shows how much higher is Guadalupe Peak than Sierra Blanca Peak. This is another word problem. I'm going to start the exact same way. Here's my question mark. I'm going to go backwards and find my question word. That word is which. Again, I'm going to look between the question mark and the question word, figure out what do I need to focus on. Which shows how much higher is Guadalupe Peak than Sierra Blanca Peak. So they want me to compare the two mountains. Compare how high up they are. Guadalupe Peak in Texas is 8,759 feet high. That's one of the ones they asked about, so I need to know this. Sierra Blanca Peak is 6,894 feet high. Sierra Blanca Peak is the other one they asked about. Here's where I might have messed up. Rounding to the nearest 100. They don't want us to just use the numbers that they gave us. They want us to round these numbers and not round to the thousands place. Round to the hundreds place. The nearest 100. I'm going to write down, I'm going to do Guadalupe Peak first. That was the first one they told me. Who remembers what was the rhyme for rounding that tells us how we're able to round or what to do? Kylie?
Five or more, add one more.
Okay.
4 or less, let it rest.
Very good. 5 or more, add one more. 4 or less, let it rest. So I'm going to circle my hundreds place. That's what they told me to round. And remember, whenever you're rounding, you always check with the neighbor, whichever place value is in front of it. So if I'm rounding to the hundreds place, I need to check with the tens place. In the tens place, I see the number 5. And if I remember that rule, 5 or more, add one more. 4 or less, let it rest. Kylie, what's going to happen to that hundreds place?
Since the 5, you have to add one more to 800 to the 700, and then it will turn to 800.
Very good. I'm going to add one more to the 700, so it's going to become 800. So that means that my number will be 8,000, because I didn't change the thousands place. I didn't touch it, didn't mess with it. 8,000. We added one more to the hundreds place, so it's 800. And then any smaller place value becomes 0. Remember, that's why they call it rounding. The end of your numbers are round because they're zeros. Okay, so that's Guadalupe Peak. I'm going to put a G for there. Guadalupe Peak. The other one was Sierra Blanca Peak. That was 6,894. Again, I'm rounding to my hundreds place. Whenever I round, I need to check the place value next to it. If I check the place value next to my hundreds, I see a 9. Ezekiel, what's going to happen to my hundreds place? What should I do to it? If I looked here and I saw a 9 next to my hundreds place, Ezekiel, what should I do to my hundreds place?
Um.
You want me to say the rule for you again?
Yeah.
Okay. The rule is 5 or more, add 1 more, 4 or less, let it rest. So if I check next door and I see that the number is a 9, what do you think it should be?
Let it rest.
So is the number 9 less than 4?
No.
No. The number 9 is more than 4, right?
Right.
Remember, 5 or more, add 1 more. 4 or less, let it rest. This is 5 or more than 5, so this is going to go up. If it goes up, Ezekiel, and I add 1 more to this, what will it turn into? If it was an 8, and I add 1 more to it, what's it going to be?
A 7.
So if I have an 8 and I add 1 more to it, it's going to turn into 7?
No.
What would happen to it, Ezekiel? If it was an 8 and I added 1 more to it, what would it turn into? What's 8 plus 1?
9.
9. So the 6 is going to stay as 6. I didn't touch it. I didn't mess with it. I didn't even look at it. The 8 turns into a 9. And then all the smaller numbers turn to 0. That way the ending is round. But now that I have my numbers rounded, I can do my problem. I can compare them. If I want to see how much higher one of them is, that means I want to subtract them. I want to find the difference. So 8,800 minus 6,900. Here's the good thing about rounding. The numbers that are zeros are much easier to work with. 0, 0. 8 minus 9. I can't do 8 minus 9, so I'm going to need to borrow. If I borrow from the 8, it's going to turn into a 7. Then this 8 turns into 18. 18 minus 9, 9. 7 minus 6 is 1. So I have 1,900. If I look at my answer choices, 1,000, 2,000, that's really close. 14,000, that is not very close. D, 1,900. On problems that ask you to round, or they might use the word estimate, make sure that you round your numbers first before you work with them. Always round the numbers first and then do your math. Whether it's multiplication, addition, subtraction, division, doesn't matter. Round your numbers first, then do the work. If you round them first, it makes your work a lot easier. You don't have to work nearly as hard, and you'll get the right answer. So, two very, very important reasons to round your numbers first. Owen used base 10 blocks to model the multiplication problem below. Okay, so they show us what is he multiplying by. Instead of using numbers, they use the blocks to show us what numbers he wants to use. It says how many hundreds will be in Owen's final product. Now, since they didn't ask me what numbers Owen is multiplying, then really, it doesn't matter to me what numbers he's multiplying. What matters to me is the final product and how many hundreds there were. There's a couple of ways that you might have made a mistake on this problem. First way, I know that in base 10 blocks, these are ones, these are tens, and these are hundreds. So the first mistake I might have made is just going 1, 2, 3, 4, 5. 5 hundreds. There you go. But I can't forget, all of these blocks are part of the same number. So they all add up together to make one number. If I just count the hundreds, I don't get that whole number. I need to count everything. So for problems like this, what I usually do is I break it up into 3 parts: the hundreds, the tens, and the ones. You can start with the smallest place value, you can start with the biggest place value, doesn't matter. Since we started counting the hundreds, I'll start there. 1, 2, 3, 4, 500. Now I'm going to count the tens. Remember, since these are tens, I'm going to count by 10. Okay? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170, 180, 190, 200. So I need to add another 200. 0 plus 0, 0 plus 0, 5 plus 2 is 7. Now I need to count the ones and add those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Let me add those. 0 plus 5, 0 plus 2, 7. Okay, here's the other mistake. Some of us did all this correctly. We added up our numbers, but then for our answer, we put 725. We forgot that's not what they asked us. They asked how many hundreds. So they don't care about the ones place. They don't care about the tens place. They only care about the hundreds place. And how many hundreds are there? There are 7. If I put 700, that's not correct, because 700 hundreds would be 70,000. That's not how many they had. They only had 7. There were 7 hundreds in his final product, his final number. So this one had a lot of different ways to trick us. Number one, by just showing us the hundreds blocks and trying to see if we wouldn't count the rest. Number two, if we did count the rest, hoping that we would forget that they asked how many hundreds, not what the final answer was. And number three, if we put 700 instead of just 7. So 7 is our answer. There are 7 hundreds in his final product. So this one did have a lot of different ways to trick you. This is a problem that they do like to use. I see this problem multiple times during the year, usually. They usually love to put problems like this, so don't fall for those tricks. When they show you a multiplication problem like this, don't just count one part of it. Count everything. Don't forget, read your question very carefully. If they ask you to focus on the tens, the hundreds, the ones, whatever it might be, make sure you focus on just that part. We're actually going to go to the very next problem, problem 21. It's another one that a lot of us had problems with. These polygons belong in the same group. They give us 3 shapes. Which statement best describes the polygons in this group? Now remember, if they're putting these shapes into a group, they have to have a reason for it. There has to be something that all of these shapes have in common, that they have the same. A, each polygon has at least one obtuse angle. At least one. That means if it has 2 or 3 or 4, then fantastic, wonderful. But it has to have at least one. So we're going to check all these angles. We're going to see which ones have an obtuse angle and which ones don't. I'm going to start with this one with my first shape. Remember, to check your angles, you can use a sticky note, or if you don't have a sticky note, you can just use a regular piece of paper. You can just use a regular piece of paper, the corner of that. The sticky notes, the reason why I like to use them is because, number one, they're smaller. It's easier for me to move them around my page. And number two, sticky notes come in nice and bright colors. I like having them in nice bright colors because then it's easy for me to see if the sticky note fits or it doesn't fit. I always start with the top angles, but that's just me. There's not really a reason for it. That's just where I like to start. I'm going to try to put the corner of my sticky note into the corner of my angle and see if I can get it to fit. When I do, I can see that, yeah, there's enough room for the sticky note, but my angle is too big. I still have all this empty space here. It's still pretty open. If the angle is too big for my sticky note, it doesn't really fit very well. That's an obtuse angle, when the angle is too big. If I check the other angle on top, I see the same thing. It sort of fits, but I see all this open area here. And again, if the angle is too big for my sticky note, it's an obtuse angle. These angles on the bottom have the opposite issue. When I try to put the corner of my sticky note into the corner of my angle and get it to fit, I can't. My sticky note's too big this time. I can see because it's covering up one side of my angle. If my angle is too small, if my sticky note doesn't fit, that means it's an acute angle. And I see the same thing happening on the other side. If I try to get my sticky note to fit, try to get the corner to fit and match up, it doesn't. The angle's too small. So another acute angle. Now I'm going to check this middle shape here. Okay. No, this angle's too big too. I try to get the corner to fit, but I can see that there's open space out here. It doesn't fit correctly. This is another obtuse angle. If I check my other two angles, I see it's the opposite. My sticky note won't fit in that angle. Or this angle. Both of those are too small. So those are my acute angles. Remember, any triangle, no matter what kind of triangle it is, no matter what size it is, any triangle will always have two acute angles. It might have three, maybe, but it will always have two. Then I have my last shape. Again, I'm going to take the corner of my sticky note and try to make it fit in the corner of these angles. Nope, that one's too big. I can see it sticking out. Nope, too big again. Nope, too big again. Nope, that's too big again. Nope, all of the angles on this shape were too big. They were all obtuse. Now again, like I told you all earlier, if there's a quicker, a faster way to do something, I will always tell you. The reason why I never tell you just look at the angles and then pick what kind of angle they are is because depending on how they show the shape, if it's not standing straight up, if they make it leaning or tilted to one side or the other, it's very easy for them to make one kind of angle look like another. For instance, on this middle shape, this triangle, if I didn't use my sticky note, if someone had just asked me, hey, what kind of angle is this one up here on top? I might have said it's a right angle. It looks like a right angle if I'm just looking at it. But if I actually check it with my sticky note, I can see that it's not really a right angle. Whenever you get a question and they're asking you about angles, don't just look at them and guess what kind of angle they are. Use a sticky note or use a piece of paper. Double check them. It won't take you very long, but it will help you find the right answer. Now that I've looked at all my angles, I can see that answer choice A is true. Each of these polygons has at least one obtuse angle. The first shape has 2, the second one has 1, and the last one has 5. B, each polygon has at least one acute angle. At least one. Well, the first shape has at least one acute angle. The second one has at least one acute angle, but the last shape didn't have any acute angles. So for answer choice A, all 3 of them. Answer choice B, only 2 of them. Answer choice C. Each polygon has at least one pair of perpendicular sides. Perpendicular, we wrote this down in our review, the one that we could have used to help us on the test. Perpendicular means that I should find a right angle. I didn't find any right angles in any of these shapes. So none of them are perpendicular. Not a single shape here has perpendicular sides. Answer choice D, each polygon has at least one pair of parallel sides. Remember, parallel means that they never, I'm going to underline that, never touch. The first shape absolutely does. The top and the bottom, if I were to take those 2 lines and stretch them out and keep drawing them forever and ever and ever, they would never ever touch. So yeah, the first shape has parallel sides. But a triangle. A triangle will never, never, never have parallel sides. It can't. If I try to stretch out any of the lines on a triangle, I will always see that they end up touching. Triangles can never have parallel sides. So that one's not true either. My answer should have been A. That's the only one that was true for all of my shapes, not just some of them.